So recently I was invited to give a talk at this Semantic Interoperability workshop. So it was part of IoT Week.
Stand close so that we can
Hey, it's fine. So it was part of IoT Week. So in Europe, Internet of Things is kind of a big deal, right? So this is like the one area where the government has really kind of thought that they can make a contribution. So they put a lot of money into it. So there's actually a lot of researchers come and are interested in these kind of things. And so we were interested in semantic interoperability. So if we're going to put all of these things up on the web, how do we get them to communicate with one another, right? And so they're interested in the W3C in particular, their work on semantic sensor networks. So they invited me to come talk about that. Yeah. So one caveat, this presentation was not meant for you guys, right? It was meant for an audience who don't really know that much about semantics and don't really know that much about sensors either, right? There are a lot of low-level hardware people. So I'll try to kind of breeze through some of this semantic things that I talk about and sensor things that I talk about that you probably already know. There's probably very little that you don't know, so just bear with me. Okay, so I start in the beginning, right? So once upon a time there was a web, right? And so that's it down there. So if the web was a garden, it might look something like that, yeah? If I was a gardener, then I could water it, I could prune it. In general, I can understand it, I can manage it, right, as a single person. And then sometime within the last few years, it grew up. And so no longer can I, a single person, a single individual, a single organization or company, manage or understand this thing. You know, the best we can do is kind of look down it and try to find a lighted path and walk, right? So something interesting happened around 2008 that I want to bring to your attention. So this was kind of the point where the rate in which data is being generated surpassed the rate at which storage capacity is being generated, right? So this is kind of, so, you know, at this time we kind of reached this event horizon, I guess. So it was the point where we can no longer naively just store all the data that we generate, right? We need to come up with some more sophisticated ways in which dealing with our data. Yeah. So who's to blame for this particular situation, right? So I blame you guys, you know, less so me, right? Because this is the point where people started getting online. You know, Web 2.0 became pretty popular. People started blogging and social networking came up. And so a lot of additional data started coming online. But it wasn't just volumes of data. There was also different types of data, more complicated types of data. So we see with Flickr, we see images, we see videos, we see mapping data, these kind of things, right? So the obvious question here is, if that's what happens when a few people get online and their opinions get online, what's going to happen when all things get online, right? So all of our sensors, all of our devices. So one example I've given 1,000 times by now is this idea of a plane going across the United States generates 240 terabytes of data. So this is a single plane, a single flight. Okay, so consider how much data is being generated by all the planes flying today, right? Or all the planes this month. You know, forget about planes. Think about how many cars, trains, or buses there are. Right? There's many more of those. Or household appliances. Right? So actually, during the conference, I just threw this up right before this talk, so bear with me here. But I gathered some interesting statistics, and it was about the number of devices that are coming online. So right now, there are about, I think they said, 13 billion devices online. In 2 years, there'll be over 20 billion. And by 2020, they're saying there'll be over 50 billion devices, all generating data, all putting their data online. Right? So you guys can probably see where I'm going with this, right? So the situation's only getting worse. So there's absolutely no way that, as people, we can comprehend this. And there's absolutely no way we can manage it. So somehow we need to enable our machines to be able to understand and manage this data for us. right? So that's the basic idea. And what we're proposing, or what I was proposing in this talk, is the use of semantic web technologies to help us out with this task. Right? Okay, so some of you might have seen this before, so several people should. Anyway, I think it's really interesting. I think the Far Side comics really understand semantic web well, right? So if you want to understand a domain, what's the first thing you do? You start labeling things. Yeah? You start naming things. You know, you say, hey, this is the tree, this is the house, this is the door, this is the dog, right? That's the first step. After that, you can start specifying relationships between things. You know, this thing lives in the house, right? This thing has a pet, the dog. Yeah? So we call these, so these are concrete facts. These are things about the world. And we have a language to describe these things. We call it the resource description framework. So this is one kind of statement. Another kind of statement is more general knowledge. So we don't want to talk about particular things. We want to talk about classes of things. We want to say, in general, a person can have a pet of type animal, right? And we have a language to describe these kind of things. We call it the Web Ontology language. Okay, so you guys know all this. But the claim I wanted to make is that when you take these two types of statements and you begin to integrate them together, so that's when the real magic of semantic web happens. And that's when interoperability can occur, right? So as an example, I don't know if you noticed or not, but this thing, it's not labeled. Right? I mean, do you guys know what that is? We're supposed to know what that is. I guess the Far Side people figured it was so obvious what that thing is that they don't even need to label it. They'll label everything else, right? But nothing's obvious to a machine, of course. I mean, how's a machine supposed to know what this thing is? Yeah? It cannot in any way take these assumptions that we make, that Far Side makes, that are implicit, and understand them at all. We need to make them explicit, and that's what semantic web does. So what can we do? So we know this thing has a pet, right, the dog. And we know that a person can have a pet of type animal, right? So we can make an inference that that thing there is a person. Right? So this is actually pretty powerful. So we took something that was assumed, that was implicit by the creators of this drawing, and we made it explicit. Right? So now a machine can understand what this thing is, and it can start making certain assumptions about it. Right? So say it wants to contact this thing. Well, it knows it's a person, so it probably has a phone number, probably has an address, probably has a Facebook account. Right? So you can contact it and maybe talk to it and ask it questions and these kind of things. This thing is probably not true of the dog. You make different assumptions of the dog because the dog is an animal. If you want to get in contact with the dog, well, maybe you contact its owner, right? So because we've been able to infer this new knowledge that was originally implicit, made it explicit, all this new data comes to us, right? And we can use it to integrate devices and integrate systems, right? Okay, so then I go on to talk about the fact that a lot of these statements are being put up on the web, and I showed that within the last 5 years that it's been tripling each year to the point where now it's up to 50 billion statements. So I got this quote during Dog Show, so last week. So it's getting up towards 50 billion statements. So that's a lot, right? And industry is beginning to take notice of this. Right, so of course the major technology players, Yahoo, Microsoft, IBM, but also content providers like BBC, New York Times. And because the industry is starting to get involved, we're starting to see some successes, right? Of course you guys know this thing, how Jeopardy and Siri, we've talked about this a lot. Then Google comes out with this knowledge graph. And then here's an example, Venice, Italy, where I can type in and get the documents for this particular string, but also I get information about the entity Venice, Italy. So we know that it has an area, it has weather, it has local time, because Google now understands that this is an entity and these are its properties. Right, so a lot of semantic web folk think this is fairly simplistic. I think it's kind of interesting, only because of the scale and because it's such a 180 turn by Google, right? Starting to acknowledge the use of background knowledge of semantics in addition to their machine learning algorithms. So that's a little bit about the web, but what about the sensor web, right? So most of you guys know, maybe some of you guys don't. The sensor web is basically the idea that we want to use the internet and the web in particular as kind of a platform for managing and accessing sensors and sensor data, right? But when we begin to look a little more deeply in this, what we found was that a lot of these systems, these sensor systems, were stovepiped, right? So what I mean is a company will buy some sensors, right? And they'll put those sensors out in the environment, they'll collect the sensor data, they'll analyze the sensor data, they'll write some application software to use the sensor data in whatever way they see fit, right? So the entire life cycle of the sensor data from end to end is controlled by a single organization. This is what I mean by sensor. And within the sensor web, we want to set this data free, right? Because we all know the benefits that come from that. But when we do that, actually problems emerge. So all of a sudden, it becomes very difficult to discover, access, and search for data, right? Because it comes from many different places and uses different protocols. And the ability to integrate data from different places and interpret the data because we don't know the assumptions that were made when the data was created becomes difficult, right? So in order to solve some of these problems, the Sensor Web Enablement project was created maybe 10 years ago, maybe a bit more, by the Open Geospatial Consortium. In this group, basically it's a huge conglomerate. It's like several hundred companies, academic partners, organizations, who came together and decided to see if they could solve this problem, right? And what they came up with was a service-oriented architecture, right? So basically, they defined a set of service interfaces. So for example, they came up with something called SOS, which is the Sensor Observation Service, which is a way to query and access sensor descriptions and sensor data, right? And then they have the SPS, which is a sensor planning service, which allows me to task sensors to do, or to engage in different behaviors. This SAS is a sensor alert service. It allows me to subscribe to different sensing events and these kind of things. And so these different services actually communicate with one another through standard XML protocols. And so that was actually a pretty good start, I think. Right? And it solved some of the problems we had. So it solved the discovery problem because now we knew how to find the sensors and sensor data we needed. Because it standardized the interface protocols, we knew how to access and search it. Right? What it didn't allow us to do was integrate and interpret the data. Like, this was still an issue. And I would argue that these are still issues because the people who implemented these services, the people that do implement these services, still make a lot of assumptions about for example, the data and the domain that they're working in that aren't made explicit within these services. Okay. I can give you an example. I don't know if that makes much sense. So say I have a weather service or something, right? And I want to detect blizzards. So maybe I have, wind speed sensors, precipitation sensors, visibility sensors, right? And then from that, I can run some analysis to say whether a blizzard occurs, a flurry occurs, a hurricane occurs, something like that, right? And maybe I can, use a sensing alert service to tell the user, hey, there's a hurricane or there's a blizzard. But the connection between that term, blizzard or hurricane, to the observations that were used in the analysis is implicit. It's not made explicit in any particular way. And so a system that wants to integrate with this one is not able to really understand what this term means. It's basically on the user of the system as a person or as a group to understand these terms. It's not made explicit. So about 3 years ago, I guess, the World Wide Web Consortium brought together a group of researchers to see if they can use semantic technologies to help solve some of these problems. So they created this Semantic Sensor Network's Incubator group. And the first thing we did is we set out to build an ontology. So what are the major concepts being used or that are necessary to be understood by all systems that work with sensor data, right? So there are these particulars, so there are some objects, events out in the world, and these objects and events have some properties, right? And they're related to stimuli information. And these properties and stimuli can be observed by sensors, and then these sensors generate observation records. And these observation records can be digitized, stored, queried, reasoned on, right? So this is the game that everybody plays. If you're working with sensor data, you have to understand at least this. And once we have this model, we begin to expand, right? So these sensors are often implemented within devices, right? And these devices can be integrated into systems. These systems have particular operating restrictions. You know, they can only work at particular temperatures or within particular locations. They have maybe particular measurement capabilities. You know, they can only measure a certain level of granularity, for example. These systems can be integrated with platforms, you know, like the plane I showed earlier, and then deployed within some environment, right? So we set out modeling the ontology in this modular fashion, right? Fairly systematic modular fashion. And the reason we did this is because we wanted to make the ontology as simple as possible. So if I have an application and I want to use this ontology, I can pull in the modules I need to add more complexity, add new concepts when I need them. But if I don't need them, I can leave them alone. And you know, I can only pull in complexity if and when I need it, right? Because we believe that, you know, the simplicity aids interoperability. Okay. But that doesn't mean the ontology is necessarily simple, right? So there's actually a lot of concepts here and a lot of relationships here. And we really did try to dive deep and understand all the different concepts and relationships involved. And while we're developing the ontology, we didn't want to forget about all the work being done in the sensor web enablement for the past decade, right? So I said that this solves some of the problems we had before. And there's organizations actually implementing this now and using it. And so we wanted to make sure that whatever technology we come up with is kind of backwards compatible, right? Or another way, I guess, to say it is, we wanted to make sure that we provide a nice way forward for people who would like to get into semantics but already have these systems implemented. So if you have a sensor observation service or any of these sensor web enablement services or any of these sensor web enablement data, you can annotate the data with concepts from the SSN ontology, right? And so if you want to integrate with a system that is, you know, semantically aware, well, then it can take advantage of these more complex, more expressive representations from the sensor's ontology. But if you want to integrate with a system that's not semantically aware, then it can safely ignore these, right? We actually went to, you know, some effort to make sure that these can be ignored. So this works perfectly well with you know, systems that have been developed prior to the semantics or the integration of the new semantic technology. Okay, and since we've developed some of these technologies, we've seen good adoption, I believe. And we're seeing more and more. Right, so, you know, here I show some of the groups using the ontology. And so we went out to some of these groups that are using it, and we started polling them, right? We asked them how and why they would want to use this semantic technology, right? And from this, we came up with 4 major use cases. So the first is data discovery, the second is device discovery, third is provenance and diagnostics, and the fourth is tasking and programming. So these are the major things that people wanted to use the ontology for. And here we just kind of show the different modules that would be involved in each one of the use cases. Between you and me, the first two are the ones that people have actually implemented applications for. Probably not so much the last two. I think this is because most of the people that use this are semantic web people or web people, whereas these bottom two use cases are more hardware sensor centric. So I actually think this integration with IoT, meaning since they're usually lower level researchers working at a different, not so much the high level web technologies, but the low level sensor technologies and device technologies, might be more interested in these use cases, so I think that integration might help us. So I'm going to give an example here about an application we developed to test the second use case, devices layer. Right? So you guys know some of this, so I won't talk about it. We created this link sensor data with some 20,000 sensor descriptions. We connected it to linked open data, or we put it on linked data and we connected it to geonames, right? And from that, we're able to do sensor discovery applications using not geo-coordinates or bounding boxes like the Sensor Web Enablement normally does, but we can actually put in named locations. We can put in James Cock International Airport, we can put in Wright State University, those kind of things, and it'll tell me the sensors around it. Right? Okay, so most of this so far has been about interoperability, integration, these kind of issues. Those of you know me, my interest is more so in the interpretation. Right? Okay, so in order to enable this interpretation, basically we have all this sensor data coming to us, and it needs to be able to tell us something about the world, right? Or we need to be able to extract what it actually means about the world. Right? So we call this interpretation or explanation or abstraction. Right? In order to enable this, we developed an ontology. We call it IntelliGo, which takes the SSN ontology, the sensors ontology, and integrates it with cognitive models of perception. Because we know that people are pretty good at this interpretation thing. One of the things that they utilize is background knowledge, right? And so we're able to actually integrate data from LOD, for example, as our background knowledge to enable this interpretation. And then I show some applications of this ontology. So in weather and fire detection and healthcare, right? So the first application, we took these 20,000 sensors that I showed earlier, and we collected the data, and we tried to analyze it. We tried to determine what kind of events could be detected and these types of things. And we found that by integrating the background knowledge and our perceptual algorithms, we actually could detect a blizzard using only 50% of the observations that were needed otherwise. Right? So that means like 50% of the time that a sensor was turned on and actually gathered or generated an observation record, that this was unnecessary. It was wasted. It was wasted for our application. And so this is actually a good resource savings. And going to the previous point I was making about the influx of data, we found that if you actually stored the event information rather than the observation information, then it was an order of magnitude savings, resource savings, storage savings. The second application was, it's called Secure, Semantic Empowered Rescue Environment. So we wanted to be able to detect different types of fires, right? Because different types of fires need to be extinguished differently, right? So, if I have a wood burning fire, I can throw some water on it. But if you guys have ever had a grease fire in your kitchen, you don't throw water on it, right? Because it'll blow up in your face. So this is the kind of information that maybe firefighters or rescue workers may need before they actually go into the situation. So we took a Roomba robot and we attached some sensors to it. carbon monoxide, temperature sensors. And we're able to detect different types of fires and different types of objects generating. And I think there's plans on extending this towards not so much little Roomba robots, but maybe wands or something like this that someone could carry around with them. So probably the most interesting application is this this mobile app we're developing to help reduce readmission of patients with chronic heart failure. Right. So I have, we all have these things, right? I actually have these things, right? So this is a sensor. It can detect heart rate, but they also can detect galvanic skin response, temperature, blood pressure, right? And by having this communicate with this, and with my phone having the background knowledge about cardiology and about different health conditions, and using our algorithms, we can actually detect different events, right? So that's the idea. So coming from the sensor, I can detect, abnormal heart rate and calamitous skin. And then using our algorithms here on the mobile phone, I can determine that, this could be the result of, a panic disorder, hypoglycemia, hypothyroidism, right? So this is pretty nice, I think, but probably not good enough, right? I mean, there's a lot of variability here between panic disorder and heart attack. So kind of, in order to narrow down these possible explanations a bit, if I were to go to a doctor, they might start asking me questions. They might ask, are you lightheaded? Right? Well, there's no sensor that I know at least that can detect whether I'm lightheaded. You just have to ask me, right? But maybe, I'm the sensor here, right? So I can determine, or I can detect whether I'm lightheaded. And this kind of observation can be annotated using the SSN ontology, just like any other, and can be integrated into the system. And so using the background knowledge, we can actually begin asking such questions. So we can ask, are you having trouble taking deep breaths? Do you have low blood pressure? Have you taken your medication? Right? And we can do this because the semantics understand the relationships between these symptoms, these disorders, and these medications. Right? So one interesting point here is the fact that all of this processing is actually happening here. Right? So the applications I showed earlier, I didn't really talk about them. I just kind of moved over them. But IBM Watson, Apple Siri, Google Knowledge Graph, these have huge servers behind them, right? Crunching, doing a lot of processing. This requires a lot of processing too, but sometimes you cannot guarantee or you cannot rely on the fact that you're going to have such internet connectivity, right? Connecting to the cloud to do this huge processing might not always be applicable, right? Particularly in healthcare applications and other things, IoT, where they want to be able to do the processing as low, as close to the data as possible, right? So
that could, by the way, also security and privacy. We can also use that as a huge driver for that.
Oh, absolutely, yeah. So this is something that I actually, I found interesting before, but actually found a very receptive audience to. Is the fact that we've been working on semantics, in the cloud with big servers, big data. Our own work is trying to put semantics on mobile phones. I think next is pushing it maybe lower to see if we can get it on gateways, to see if we can get on, consumer electronics, get it on different kinds of applications. So actually at Surrey, I found that they have an infrastructure set up. So in all the rooms in their building, they have sensors and they have gateways, right? And so one thing we talked about is the possibility of taking our algorithms and trying to run it on those gateways. So that might be interesting.
But there will be a limit on how much you can run on it, right? There'll be a limit on the computational aspect of it. It might be the gateway or the mobile phones.
Absolutely. Yeah, that's what makes it a challenge, right? So there's actually several things here. The first is if our background knowledge is up on the web, but we need to do the processing within the gateway. So how do we get that knowledge down to the gateway? We can't pull the whole web down, right? So how do we actually go and find the information we particularly need and pull that down? So this is a difficult problem. How to find the information you need and ignore the information you don't need. The other is that most of our semantic web technologies have been developed for the web, right? So RDF, OWL, these are kind of obtuse, kind of compared to the machine-to-machine protocols that people are used to for this kind of thing. Semantic web technologies just aren't really applicable, right? So coming up with new languages, new encoding schemes for this new kind of framework, this Internet of Things, is, I think, is pretty interesting. So that's it.
Excellent. Very well done. What were the questions that were asked? If there
There were some decent questions asked. Mostly, so they wanted to know what applications were being developed using the ontology. For that, I had to say that most of the applications were web applications. Right? They were not, low-level sensor applications. They weren't Internet of Things applications. So they were mostly like the application I showed earlier for device discovery, right? So taking sensor descriptions, putting them on LOD, connecting it with other data on LOD, and then able to do some more sophisticated queries. Right? So that's about the kind of applications we've done. And then most of the other application questions were kind of along the lines of, did you include this or that within the ontology, and if you didn't, why not? So some people were interested in actuation, so the ability to task sensors and to manipulate them using the ontology. But we can't really do that yet. The other is trust, of course, right? So people wanted to know or how integral trust was within our ontology. And at this point, not so much. Right? We haven't really gone. It's a difficult problem, so we haven't really stepped into that area yet.
I think we can do that now. Given the other work we have on the trust, that may be well worth an extension where you can actually put it out there.
I think so. Yeah. I think no one's really just stepped forward to do it yet. I think it's necessary in order for practical applications.
Do they consider about the scalability aspects?
Just who-
Scalability aspects?
They do. I don't know. So it's hard to say. So people give a lot of lip service to scalability, right? So I gave this. So I showed these stats where they're saying, oh, we're going to have 50 billion, devices. And then there was one guy who he said he would have these devices and all of this data. But most of the work I saw was more localized. So it was, how do you get this thing to connect with this thing and talk to one another and share information with one another, right? Or how do you get the sensors and devices in a room to kind of collaborate and integrate with one another? So yeah, there was talk about scalability, but I didn't really see anything too shocking.
Interestingly, we actually have taken the problem that are appropriate for large scale. So Cory started with talking about 20,000 sensors in Mizuwa's demo that we did. That's a large scale. The point here is that it is reasonable to be able to ask a question whether this kind of phenomena or is occurring anywhere in the United States today. That's a reasonable question. I'm interested in the weather in the thing. So we have made a sensible we have taken sensible applications that may indeed utilize tens of thousands of sensors if you want to. Right. So I think that's very interesting. The other thing is that very exciting thing that we are doing is that to the sensor data we are integrating more of a social data at the same time. So the sensor data, social data, link open data, all these are coming together in the things that we are considering now.
So this might actually be something that we can bring to the table for IoT. So most of the talks that I went to, like I said, were between devices and between machines. There was no talk of web, really, right? The web doesn't even come into the picture. Like I talked about web more than any other talk I had seen, right? It's just not something they're considering. So they're not considering web scale things.
I think the whole of Semantic Web is looking at much more smaller things that they are tending to move from Semantic Web to just semantics, so that they restrict their domain and get a better value for the information you try to use or the background knowledge you try to use. That is what I think is happening.
I don't know. I agree and I disagree. So people are, I mean, the LOD is kind of the example of people using the web for this kind of thing and integrating data at a large scale. But for these kind of applications, I also have seen the tendency, which I'm particularly interested in too, is what they call downscaling the semantic web. So not only, scaling it up to this huge infrastructure, but scaling it down to be able to use it on small devices. And the question is, what is the interplay between the two, right? So I said before, these devices need to know what's happening up on the web, but they don't need to know everything that's happening up on the web. They just need to know little pieces of the pie that's interesting for them.
Yeah, for them, for some application, it would be simply consulting an encyclopedia. That's accessible on the web, that's it. But other than that, everything is, fairly local. But the point here is that what is more powerful when you talk about semantic web, I think we've gone through the time where web is extremely powerful. The fact that so much data is on the web. I think we are entering the time where people will really understand that semantics is also extremely powerful and that can really solve very important problem. So, a very broad analogy is that when Google argued for the use of big data and a lot of data to understand anything that you want to understand in the world, and that paper that you guys you might have seen about give me all the data and I'll tell you everything that you want to know, like Halevi and other Raghu Ramakrishnan paper. Yes, unreasonable effectiveness of big data, and vis-a-vis the fact that indeed in the Google Knowledge Graph, using and improving upon freebase is a huge contributor to the kind of stuff that you can do now next, which is indeed a complementary and very powerful thing to just the big data part of it. And so I think we'll see a lot more opportunity of applying semantics. The work that we've done and this ISW submission about doing limited reasoning on the mobile platform, smartphone, again, that is irrespective of web. It's really, you can take the whole web out of it and still be important, other than the fact that I'm using internet to communicate with some other devices if I need to. So I think some success of semantic web will spill over, but I think the semantics has a lot thing to play when you go to devices that may or may not worry about web. And in that sense, I think it will be very interesting. All right, let's end it there. Thank you, Cory. Great job.